Okay, the last lesson for Unit 1 is actually Newton's laws. So this is basically how do you connect forces to the motion that we saw in the early things. So, Isaac Newton basically expands on the work of a guy named Galileo to create 3 laws that explain all motion and forces of everything in the universe. Newton's first law is basically inertia. It's that basically things want to keep moving. Nothing ever really stops. Newton's second law connects forces to acceleration, and Newton's third law explains what happens when one object puts a force on another object. So, first law, an object at rest or in uniform motion will remain in that state unless acted on by an external unbalanced force. It's also called the law of inertia. So a lot of people think this is an object in motion will stay in motion. It actually isn't that easy. An object at rest will also stay at rest. Things will basically keep doing what they're doing unless you apply a force to make it do something different. The way I like to think about this is matter is lazy. It's going to keep doing what it's doing unless you force it to do something different. Unless you give it a force that basically an unbalanced force, so more in one direction than all the others, it's not going to change what it's doing. If it's moving, it'll stay moving. If it's at rest, it's going to stay at rest. So, 2 things that are important there. The first is the force has to be external, okay? You can't apply a force to yourself. So a guy sitting on a skateboard, unless he puts his foot down on the floor, there's really no way he can make himself move, okay? You can't, lift yourself off the ground. You need to apply a force on something else. So you'd have to put your foot down on the ground to actually give you a force forward. The second law tells us how much an acceleration of force gives us. So this is the math part you're going to be doing. It's actually not hard, it's just multiplying 2 things. So the acceleration of a force is determined by 2 things: how big you push it and how big it is. So F is the force in newtons, M is the mass of the object in kilograms, and A is the acceleration. So if you know the force and the mass, you can figure out how much something is accelerating. If you want a certain acceleration, you can figure out what the force needs to be. The mass hopefully will stay the same, otherwise that means it's exploding, so we try to avoid that. Newton's third law basically explains why your skateboarder moves. When you push on the ground, you need a force on you to make you go. So when you push on the ground pushes back with exactly the same amount of force you're pushing forward with. And if that force is bigger than the force of friction, you'll have an unbalanced force that will change the motion, create an acceleration. Your skateboarder will accelerate forward. So, Newton's third basically says, for every action there's an equal and opposite reaction. You need to add the word force to that. So if I push on you, you push back on me with exactly the same force, and that's the force that makes me move. So, a good example of Newton's third law is, recoil in a gun. Gun puts a force on the bullet, bullet puts a force back on the gun. Bullet goes much faster because it has much less mass than the gun. The gun still goes back, but the bullet goes forward very fast because it's got a very little mass from the same force. A rocket is exactly the same way. When people ask, how do rockets work in space? There's nothing to push against. Well, rockets actually push against their fuel. You push the fuel out the back, that pushes the rocket forward. It's the reaction force of the fuel on the rocket that's actually making the rocket go forward. So that's Newton's laws. The only math you're going to have to do for this is Newton's second, the F equals ma. Again, just look what's the force, what's the mass, what's the acceleration. Plug the numbers in, you'll get an answer. All right, good luck.